The practice of moving fly forms from one level up to the next is high risk. There have unfortunately been multiple incidents. In some of those incidents, there have been fatalities. Simply put, when things go wrong with fly tables, they can go very, very wrong.
Fly tables is one of the higher hazard procedures that we do on site. A lot goes into it in terms of the procedure and controls to prevent those hazards.
Any crane activity comes with inherent hazards, but cycling fly tables, there's more moving parts and there's more coordination required, which just ups the ante for something to go wrong.
We're up high, we're on the edge, we're building these buildings. It's all heavy-duty construction, so there's a lot of working pieces, a lot of moving parts. Everyone has to be on point, focused, and paying attention to their task at hand.
These are large, complex operations, and people are at very high risk of getting hurt.
As a result, WorkSafe BC is trying to do everything we can to put everybody involved in a position to do this work safely. The fly table process can kind of be broken down into 4 phases. The first phase is the dropping phase. In this phase, the table is lowered from the hardened slab. The next phase is the rolling phase. In this phase, there are wheels or casters that are attached to the fly table, and then it is moved partially out the side of the building, far enough that the crane can completely attach to the table itself. Phase 3 is the lifting or the flying phase, where the crane picks the table up, takes it out the side of the building, and then flies it up to the next level. And then the 4th phase is the landing of the table, and it is secured to the point where it can be disconnected from the crane.
Fly tables are large, heavy, so the hazards associated with them are simply their size and their position, also the proximity that they are to the edge of the building, so they can come out of the building, fall, and strike a worker at that point.
Another potential issue is structural failure. While the table is being cycled, if one of the components' strength is exceeded, then that component could fail and then the table could fall down onto a worker. Fly table work is done at height, so falls from elevation are another hazard that has to be effectively controlled.
Everyone must have fall protection training, wear full fall arrest systems when they are near the edge.
It's a long list of things to worry about when you're flying tables.
The cycling of fly tables meets the definition of a critical lift. So to ensure that that higher risk is adequately controlled, there are these additional requirements.
The contractor needs to develop a critical lift plan, which has consideration of the weight that's being lifted, the rigging that's going to be used, wind speed.
Windy days, you're not able to fly the tables. Potentially you have the fillers and other material on top of the table that could fly off and come down.
The other requirement is to have a pre-lift meeting before hoisting activities begin on that particular day. All the different lift plans will be reviewed in that meeting, and then the workers, they're clear on what needs to be done. They can go out and cycle the table safely. The engineered drawings for fly tables are critical. It requires site-specific engineered drawings to be prepared. And so the formwork engineer goes through the process of designing all the individual tables so that the formwork trade can assemble those individual fly tables prior to them being moved up into the building. The drawings also go into details on the cycling process and the crucial steps that need to be followed when the tables are cycled from one level up to the next.
Engineer drawings are probably the most important part of the table drawings. We build the tables to the exact specifications of the engineer drawings. Before we pour concrete, a certified engineer comes in and inspects the tables to make sure they are built the proper way as according to the drawings.
Manufacturer's instructions tied in with the engineered drawings are critical because it's their product. They know what their formwork systems can withstand. So it's critical we follow manufacturer's instructions when initially assembling the table, but also in inspecting and maintaining the table so that we are always within manufacturer's specs.
The information from the engineered drawings and the manufacturer's instructions, the safe work procedures incorporate that information and then expand upon it and add the additional steps the workers need in order to do that work safely.
Safe work procedures deal with the mundane and the extraordinary. That's a chance to identify the risks and how we're going to mitigate those risks.
Before we start our tower, we'll go through a table talk between the whole crew and we'll go through the whole safe work procedure.
By having them all together, is when you have the ability to find all the potential hazards and risks and being able to find ways to solve the problem.
Floor by floor, there's always small changes. So make sure that that's addressed with the workers first thing in the morning, so that even workers that are working 4 floors below know it's table day, know what's going to be happening, know what they need to watch out for.
It's got to be done as a collaborative process to ensure the safety both for the workers performing the activities, looking after the prime contractors, and the public safety down below.
On the communication side, you have workers that are on the level where the table starts. There are workers on the level where the table finishes. You have the crane operator. You have the spotters down at grade level or lower levels. They all have to be communicating and working together as a team.
It's not just about telling people something or telling them what to do. It's confirming that they've understood and know what to do. That's critical to good communication.
As activities happen, the workers working in the same areas are very loud when they're talking because they're constantly communicating about every movement, every piece, every item, so the whole team is on the same page. Radio communication is critical between the crane, the riggers.
The bottom rigger, for instance, will let the whole team behind him know what he's planning to do next. And it's the same with the top rigger as the table's coming in. Top rigger has to make sure that everyone knows what's going on and what her next move is.
The guys are working at heights. We're working with cranes. Multiple crew members are involved in the procedure itself, so communication is key.
We often think when it comes to procedures and engineering drawings that it must be that this is how it's going to happen on the job site every day, all day. But that's not exactly true. Things happen every day that we have to adapt to conditions as they come about.
A lot of times when we look at incidents involving fly forms, there was a change somewhere along the way, and that helped contribute to that incident occurring. So it's very important when unexpected conditions are encountered, everyone involved takes a step back and really walk through what all the potential consequences are of this change.
The first step in change management is stop. Let's talk about it. Let's look at the drawings. Do we need new drawings?
When plans are changed itself, we do get the engineers involved, and then we will create safer procedures based on the engineer's recommendations.
Everyone that's involved in that process needs to understand that a change is happening. They need to understand what the change is, and they need to understand what their role is in that change.
The crane operator is ultimately responsible for the lift, and they coordinate the crane activities with the activities of the other members of the crew that are doing that to make sure that things go smoothly.
Just the nature in which the crane operator needs to slew the crane and move the trolley in order to keep the crane hook in the proper position, those are all challenging things to do.
The crane operator is really following the instruction from the riggers below. So they're kind of the middleman in all the communication to make sure all the operations go together of what's happening down below, what's happening up above on the slab, and then what actions are actually happening with the crane as they're ultimately responsible for making corrections to how the hoisting is going and overseeing the overall operation of the lifting. In our safe work procedures, the safety measurement of when extra measures are needed on the edge of the slab is whenever the wheels are getting within 300 millimeters of the edge of that slab. So to minimize the risk, we use a kicker block or a curb at the edge of the slab. So in the event that the table is rolling out further than it should, it will hit the curb and stop it from coming off the slab.
We also use what we call a brake line. That's a rope that's tied to the back end of the table, anchored back to a column or a solid structure. And what that does is it controls the momentum of the table rolling out towards the edge so that you cannot build up too much momentum to the point where you can't stop the table.
It's all about risk management basics, and it's putting effective controls in place to reduce the risk. The atypical or non-typical tables tend to be the ones that are close to the edges, and they're of unusual shape. They're often awkward to maneuver, so they need to have a plan for that lift, and they need to go over that plan and make sure everyone's aware right before the lift happens.
The corner tables are a little bit unique just because they're not your typical fly in and out tables. They are sitting on the corner of the building. They're a lot skinnier. Typically, we tie those tables down right away with ratchet straps or coil rods before unhooking it from the crane Just because they are so skinny and so small, we don't want them to tip over.
When there's a table that's not typical and has to be flown out in a different way, we have to have a coordination meeting, because if a table is being manipulated in a certain way, maybe fall hazards are different, maybe inspections have to be done in a different way. That's up to a general contractor to communicate that to the site.
For falling object prevention, the intent is nothing falls ever, and that's the goal. So we start by a couple simple principles. Never having materials anywhere near the edges that don't need to be there. Never having tools by the edges that don't need to be there. So you only have things that are needed for the work.
Policy on site is that all workers working on the leading edge must tether all their tools and equipment to themselves or back to some sort of structure. And all equipment that's on the leading edge gets tethered back as well.
You'll see on some projects there are actually screens at the leading edge that prevent any material tools from coming off the side of the building. And another control that can be implemented is catch nets that extend off the side of the building, so it's going to fall down 2 floors into that catch net as opposed to 37 floors down to the ground.
We do clean up around the outside of the tables, any garbage, anything that may come down as we're dropping tables. We also tie all our fillers off with rope that are attached to the tables.
If you can get good coordination with these things, you can eliminate a lot of the hazards. There are parts of the regulation that talk about if something is being lifted above workers, that workers need to be kept out of that area where the object can drop.
The exclusion zone is specifically an area where nobody can enter it. It is a last resort fail-safe, so that if something falls off the building, it falls in an area that's excluded from all personnel, public.
In morning meetings, we discuss where they're located so that we can coordinate trades to work in other areas while those exclusion zones are set up.
So they really need to figure out how large that exclusion zone needs to be. But it also means that there needs to be people down at the bottom making sure workers don't enter that zone. So signage, delineation, spotters, training, supervision, all of those things are critical to make sure that nobody is in that exclusion zone.
Exclusion zones moves around potentially all 4 sides of the project, and it requires a very diligent coordination so everyone knows the timing and the communication of when these zones are being taken down and put up on the different parts of the building.
Stair access to the next floor is part of our regulation, and it speaks to the ability to easily and safely access the next level when the work is happening.
It is much less hazard hauling those items up a set of stairs than it is trying to take them up a ladder.
Stairs need to be incorporated in the design. They need to know where they're going to put the stairs, the space for the stairs, and sometimes even have them engineered to be on the side of the fly table when they're flying them from level to level. So it's important to know in the design stage where they're going to put the stairs. Two main functions of the prime contractor, of course, are to ensure that coordination happens, that everyone knows what they need to do and when they're going to do it. The other main function of a prime contractor is to establish and maintain a system that will ensure compliance.
So as the general contractor, we're not just passive and hand it off to the subcontractor and trust that they're doing the job correctly. We ensure that we're reviewing all the shop drawings, we're reviewing the job procedures, we're making sure the inspections are performed at the right times. We're ensuring that their quality control lists are signed off and the deck is safe for other trades to use.
We may not actually perform the work, but it's important for us to work with our contractors that are performing that activity so we can help them and work with them to develop hazard and risk mitigation strategies. So we can share that same knowledge with our other contractors that are in the vicinity.
Equipment and work processes need to be inspected regularly so that unsafe conditions don't arise.
A lot of the equipment will have manufacturer's instructions, and the manufacturer's instructions lay out the maintenance schedule and the inspection schedule for these pieces of equipment. And if there isn't any, getting some advice from qualified people how often, what they should be looking at to absolutely ensure that those things are not going to fail while the work is happening.
So after every floor, after you finish your tables, We usually dedicate one guy underneath our tables to do a full inspection. We inspect the spindles, just make sure there's no cracks in our feet, make sure all our quarter pins are still in, because when you drop the table, sometimes they can pop out a bit, just to make sure that everything is still in good working order.
Before we pour the concrete, we inspect the table again to make sure all the reshoring is in place, everything is up to capacity, and we are able to pour the concrete.
The more eyes having a look at the work, the process is just going to make everything better and going to minimize the chance of anything ever going wrong.
It's incumbent on the workers, the supervisors, the employers. Everybody has a role to play. The training that a worker requires is really dependent on what their role is. That said, the expectation would be that workers have sufficient training to enable them to do the job safely right from the get-go. And they are going to learn with experience to help make sure the lift can go safely.
If you're new or you're from another employer, you're better off just standing back and watching what's happening. Give a hand where you can when you know you're safe, and eventually they're going to get in the routine.
The experienced workers, they have to teach, they have to coach, they have to talk to those younger, inexperienced workers. And in return, the younger, inexperienced workers have to feel strong enough, brave enough, safe enough to be able to ask those questions.
When it comes to flyform safety, the one word that comes to mind for me is system. There needs to be an effective system in place to cycle the tables in order for that work to be done safely.
Coordination of activities, clear communication, and well thought out procedures make it a success.
I hope we continue to improve on our fly tables and get to a zero incident across all the industry. And young people feel safe to come into the industry and proceed with the work that we've been doing for so many years, finding ways to improve it.
It is so important for us to understand that fly table activities must be done flawlessly every time. So we have to work together with the engineers, the formwork contractors, the prime contractors, and the other workers involved to ensure that we understand when those changes happen and that we can come up with solutions to manage that change.
It's how we approach health and safety. With the right controls in place and the right risk management in place, fly tables can be a controlled risk that is safe for workers to work around.